Welcome to my channel. In this video I will try to repair this projector. It has a broken glass and this micro ammeter. Also it has the glass broken. I already cut a piece of glass, a rectangle of glass for this projector. I used this tool for cutting the glass. I will apply some silicone here and we will disassemble this meter. We must use a black silicone, but I have only here a white one. We must remove the plug. Now I will apply here. Now I will put the glass. I will remove the excess. Now I will remove the So the glass is in place and the silicone is almost hardened. This one will replace the OLED projector. This one has a yellowish color. It has 4K Kelvin here, 4000 K. And this one, they said from 5K to 7K. So this one has a white color. Check the color before buying the projector. Now we will disassemble this analog meter in order to replace the glass. We have here 4 flat screw. I must use a sharp screwdriver. Gently remove the, it's not a glue, it's some sort of silicone or, now it's opened. Okay, we can here found the screw, they are tiny one. We have 4 screws, 4 tiny screws. We must remove them before they get lost. They are not magnetic. So here we have this ammeter. We can see its brand. Maybe Italian one, Cassinelli and Milano. I found here radio museum, in the radio museum. Can zoom out. So it's the Italian brand. We have here I will clean it before putting some glass. So the glass here, it held by this sheet of metal with this screw, and it's glued here. Now I will remove this screw. They use metal insert. I must put it here, for example. This is for adjusting the position of the needle. You must clean first. Must clean all the it has a black glue, or maybe it's a backlight. The backlit, use it back in the day. There is a groove here for the sheet of glass. Two grooves here to hold the glass there. So we must find a glass with the same thickness. The outlet glass has a thickness of about 1.3 millimeter, but this one, it has a 3 millimeter thickness. So I must find the one with the right thickness in order to enter inside those grooves here. This one, there is a groove here which held the glass in place. I open my box of lenses to find those two glasses. They are a filter for a 3 LCD projector. I will use one of them for this meter. We have almost the same width, and the lens is okay. Those lenses are colored, so I will choose the right one. I will use this one. It passes more light than this one. I must use sandpaper to reduce the width, because we have a little. We can't use here this cutter. We must reduce 1 millimeter of width in order to get the glass fit inside. I will use this sandpaper with this piece of wood. First I will do a chamfer here, the same as this original glass. Then I will reduce the width. I will do this outside in order to get the bench clean from the dust. After some patience, I managed to reduce the width of this piece of glass. After some cleaning, I will put the protective glass in the place. Now it's cleaned. Now it fall in the right place. I will put those metallic bracket. They are used to hold the glass in the right place. I will search for the. It's not magnetic. It's not. I will try to get the tweezers. I will put like this. I will put first the screw, then I will align them, the screw and the bracket in the same thing, in the same time. Now it's in place. I will do the same thing with the other screw. I will switch to the other side. Now we have the glass in position. I will put the meter. The needle is too tiny and it's fragile. If you touch it, it will be bended. I will see if there is any dust in the inside part. Now I will try to put it together and see if the needle doesn't touch the glass, because it's slightly bigger than the original. Now it moves. I will try to measure the resistance of the winding. I will use ammeter. It will send a little current here and the needle will move. Here we have the plus. I will touch first the negative, then the positive. We can see here that this multimeter, when using the ammeter, it will switch the range, and each range has a different current. Now it will try to with 10 microamp, and then it will switch to a higher current. We have 1.6 kilo ohm, the resistor of the winding. To protect the meter, we can insert in here a tube diode. We can see here in this schematic for an OLED analog and digital multimeter. We can see here that they protect the microampere meter here with two diodes. This will limit the voltage to 0.6 volt at the maximum. Now we will try to make a 5 volt voltmeter with this microammeter. So we have here, we will add a resistor. We have here the microammeter with its internal resistor. This is the resistor of the winding. So at 5 volt, this one we can measure. It's 1.6 K. I will measure the value of the resistor. I will try to touch only one side. It's 1.664. So this one is 1.664 kilo ohm. We will find this resistor. So at 5 volt, we must have a 50 microamp current. So we will calculate the total resistor and we will subtract this one. So R equal E over voltage over intensity. We will now try to calculate at 5 volt over 50 microamp. 50 microamp. 100 K. So we must a 100 kilo ohm resistor. So this one, we will calculate this one. It's 100K minus 100K minus 1.664. So R, this is the internal resistance, equal to 98.336 kilo ohm. We can put 100K, but we will not have a precise reading. We can negligate this value. So we will put two resistors with a variable resistor. If we choose, for example, a 47K multiplied by 2, and we can add a 10K potentiometer. So we will put two resistors of 47K, this one and this one, and we will add a variable resistor, a potentiometer, in series with the meter. So the total value will be 100K. This might be 10K. We have here 98 minus 47 minus 47, 4 kilo ohm. So we can choose a 4.7 or 5K or 10K potentiometer. I will grab the component. I will put them in this breadboard. Now I inserted two 47K resistor, this one and this one, in series with the potentiometer. So we have here 47K and 47K with this potentiometer and the internal resistor. We must get a 100K resistor. So here we have 5 volt, as you can see. Here we have 5 volt. We can vary the voltage. it's very easy to read those OLED ammeter than the digital one, because here if we see the position of the needle, we immediately know how many current or voltage in the circuit. We can adjust here for the calibration. It's the easiest way to calibrate the voltmeter, only with this tiny potentiometer. We can adjust here a 5 volt. You can see here. Of course, the precision of the calibration, it depends on this one. I will try to. It does not have the fine tuning, this power supply. We can here, as you can see, if I vary this potentiometer, we can see that the needle here a variation. I will try to zoom on the ammeter and the potentiometer. This is the easiest way to calibrate the voltmeter. No proprietary software or another setup for calibration. We adjust the needle to be exactly at 5 volt. Here we have the minimum and here we have the maximum. We can see here we have a Fluke multimeter, and here we have the Beckman Industrial, which was repaired in the previous video, and we have a analog ammeter. Now it's mounted as a voltmeter, so we can compare the paragraph. Here it's reactive than this one. Those two are in manual mode, not automatic range, auto range. We can see here if we vary the voltage, this paragraph is smoother than this one. Of course, it depends on the speed of the internal processor of the meter. But the two are not compared to the smoothness of the analog one. Now we come to the end of this video. Thanks for watching and have a nice time.